Problem number 4 is very similar to problem number 1. It's just simple stoichiometry, no gases involved, no limiting reactant involved. The only maybe difficulty you can find here is that you need to work with Avogadro's number because they are giving you molecules of one of the reactants. And as we have already done in all the previous problems, we will start from the data we have, and from here we need to get 2 molecules of water. As both substances are in molecules, it may be easier than transforming from one unit to another. So let's see what to do. We have 3.4 times 10 to the 24 molecules. Okay, this is supposed to be a number 4. Molecules of oxygen. This is our initial data. Then I need to use Avogadro's number to transform this into moles. So 6.02 times 10 to the 23 molecules of O2 are 1 mole of O2. Then I use the mole ratio between oxygen and water, that is 1 to 2. So it is 1 mole of oxygen that produces 2 moles of water. And again here we need Avogadro's number now to transform the moles of water into molecules of water. We know that 6.02 times 10 to the 23 molecules of water are 1 mole of water. Let's cancel units. Molecules of water here with molecules of oxygen and molecules of oxygen. Moles of oxygen, moles of oxygen, moles of water, and then we have molecules of water. That is what they are asking for. If we do all this, is 3.4 times 10 to the 24 divided by, okay, here, before we do all these calculations, as we can see, we have 6.02 times 10 to the 23 here, and we have it here, so we can also cancel this. So the answer will be 3.4 times 10 to the 24 times 2. And that means we have, let's write it here, is 6.8 times 10 to the 24 molecules of water. This is the answer for problem 4, section A. Of course, as you already know, you can solve these problems by different methods, but this is one of the most recommended methods by me because it will make you practice using conversion factors. So let's go to part B.